If I need to find the value of angle A, I know that the angles in a triangle have to add to 180 degrees. So that's the property that I've used right here in this diagram, or in this particular calculation. I've taken that angle A is equal to 180 degrees minus the 53 degrees and minus the 90 degrees in the corner. And I got 37 degrees for that. Now to get side A, you can use the Pythagorean theorem because it's a right angle triangle and you know the length of the hypotenuse and you know the length of a short side. And side A is the little short side that we have at the bottom here. So I just went through my process and I found that side A is equal to 4.13 units. Now, these two triangles that I have, ABC and DEF, are similar to each other because they both have 90-degree angles and they both have that 53-degree angle in the corner. By default, angle D, if I were to calculate it, angle D would equal 90 degrees minus 53 degrees, which is the same calculation we used for angle A. So these two triangles have exactly the same shape because their angles are the same. Okay, so we know that they're similar because of that. Now, if I want to determine the values of angle D, which I forgot to actually write on here on my piece of paper, so angle D, I just said what we would do for that. Angle D would equal the 180 degrees minus the 90 degrees minus the 53 degrees, which then gives us the 37 degrees, which we also know because they're similar triangles that the angle A would correspond to angle D, so they have to equal each other. All right, the next thing we need to do is figure out side D's length and side F's length. And there's a couple of ways to do that. I'm just going to point down here to solution number 2 for a moment. Solution number 2, I know that the 13.6 side corresponds with the 6.8. So what I've done down here is I've divided them and I got a nice answer of 2. That means to go from this side to this side, I'm really timesing by 2. That's my scale factor. That means if I want to find side F, it corresponds to the 5.4. So I would take the 5.4 and times it by the scale factor, which is 2, and I would get that side F. And likewise, I know that my A value is the 4.13, so I could times it by 2 to get the value of side D. So that's the easy solution for coming up with side D and side F. On the next slide, I'm going to show you the proportional solution, solution number 1 that I have written here, just to review that because we will eventually be needing to work with the proportionalities. Okay, so solution number 1, I've set up my ratios of my side lengths, the corresponding side lengths. Here's that 13.6 being divided by 6.8, that's our scale factor, and I've subbed in everything else that I know. And then when I go to solve for F, I'm using, let me just grab a different color here, I'm using these two together, which I've written, whoops, undo, there we go. I've used these two ratios together, set that up, and then to solve for F, it's being divided by 5.4, so in pencil I wrote multiply both sides by 4, I also get 10.8. So this is a little bit more complicated in terms of work, but when we don't have a nice integer value for our scale factor, it works out nicely. It also helps us with other proportional solving that we need to do for other situations. Now, when I went to solve for side D, I took this with this and compared them. So that's what I have written down here. And then to get D by itself, it's being divided by 4.13, so I multiplied both sides by 4.13, and I got D also equaling 8.26. Okay, now let me explain this chart here. On my chart, I am working with two different triangles. I've got my little triangle ABC, which is up at the top, and then we've got the larger triangle, which is the side lengths are all 2 times the side lengths of triangle ABC. I've got my triangle DEF. So the measurements that I have in this chart so far come from the diagrams up above. So my angle is, when I have my column here of angle, I'm talking about the angle of reference. So I'm using angle C as my angle of reference. The hypotenuse is my long side, so regardless of which angle I'm looking at, my hypotenuse is 6.8. So even if I use angle A as my angle of reference, my hypotenuse will still be side B, it'll still be side AC, which will still be 6.8. So we can fill that in right here, right now. AC will equal 6.8, or little side B you could call it. You can either use the two letters that form the endpoints of your side or the lowercase letter. So our side B is our 6.8. Now, this is where things get tricky in terms of you need to know what your angle of reference is. So in the first line here, I'm using angle C as my angle of reference. The side that's opposite to angle C is side AB, or little c, because that little side C has to be across from the big angle letter. And little side C we know is 5.4 units. The side that's adjacent to angle C would be side A, or side BC. And we calculated that, and we found that that side was equal to 4.13. So you can fill this in with 4.13. Okay, and then we're going to calculate things to 2 decimal places. We're going to take our opposite side, so whatever side is in this column goes on the top, divided by the hypotenuse, and our hypotenuse was the blue calculation we have here. So my values for opposite were 5.4, and the value for hypotenuse was 6.8. So that's what I have here and here. And when I did my division, I got about 0.79. I just went to 2 decimal places as it requested. My second calculation that I'm going to do is the adjacent side length, which is BC, which was 4.13, and we're going to divide that by the hypotenuse, which is side AC, which is 6.8, and then you're going to calculate that to 2 decimal places. So you can stick that into your calculator and take that to 2 decimal places. Next, what you're going to do is take the opposite side, which we know is the 5.4, or side AB, 5.4, and divide it by the adjacent side, which was 4.13. And again, you're going to put that into your calculator and take that to 2 decimal places and get your answer. Take it to 2 decimal places. Okay, so you're going to fill in the rest of this chart based on the side lengths that you found up above for the 2 triangles that we have written up above. In terms of the second line, you're doing it in terms of angle A as your angle of reference. So the side across from angle A, or a side opposite to angle A, would be little side A, which we know would be 4.13. And then the side that's adjacent to my angle A would be side C, which you can fill in with the 5.4 because we know that that's what that is. Okay, 4.13 here. And then you go ahead and take whatever you have as opposite. So in this case, the side that's opposite angle A would be side A, and you're dividing it by the hypotenuse, which is side B. So you're going to fill in your numbers, do the calculation to 2 decimal places. Your adjacent side, if angle A is your angle of reference, would be C, and it's divided by the hypotenuse. And then your opposite is A, and it's being divided by adjacent, and adjacent was the C. So do those calculations and then continue on with triangle DEF using those side lengths. And then you can move on to the back side of the sheet.